everyone, we are in our new chapter, chapter 9, and so in your packet you need to be on page 9, so chapter 9, page 9, and this should be pretty quick. Some of this you've already seen, but we didn't focus on it too long. It was just kind of like a little intro, and today we're going to go more in depth. So what we're going to do now that we've done factoring is we're going to start looking more at quadratic functions. And so just remember of what a quadratic function is when that highest exponent, we call it the degree, is a squared. And so when we do this, we might see 3 terms, we might see just 2 terms, or we might just see 1 term. So just realize that they're all going to have one thing in common, again, that the degree is 2. So what we want to go over today is what the 3 forms of a quadratic function are, and what their particular key characteristics that are going to help you when they're in that form make a graph. So our first form is called standard form. So standard form you've seen before. This is what we were factoring with. There are no parentheses. It's just all addition and subtraction. And so A, B, and C are going to be numbers. So A and B are what we call the coefficients, and C is what we call the constant. And then in the equation, we're going to have x and y staying as the letters x and y. All right. The key point that this shows us is going to be when we start to graph is the y-intercept. And you're going to see all of this in a little bit of why that works. And since it's going to be a point on our graph, there's going to be an ordered pair. And that ordered pair as a y-intercept is when x is always going to be 0. And what will happen is when we put 0 into our equation, you're going to see something crazy happen, and you'll only end up with the constant at the end. So this right now is just kind of like the little shortcut. The next form is called vertex form. So this one is still a little new for us. It looks like this. Okay. And what I want you to start to notice is that when you start comparing one form to another form, that they're all going to have x, and they're all going to have a y, and they're also all going to have an a, and we'll talk about what a does in a little while. But in vertex form, the key point it shows you is the vertex of your shape. And you're going to get that vertex shape. Again, it's going to be an ordered pair. You're going to do that by taking the opposite of the h value, and then that becomes your x-coordinate, and then the y-coordinate is going to be the k value, but you're not going to do the opposite of that one, so we're just going to write k. And then the last form is factored form, which is what we worked so hard to get last chapter, and it looks like this. So again, you're seeing that x and the y, you're seeing a again, and somebody chose these letters P and Q. I don't know. But what factored form is going to show you, and it's one of the reasons why we worked so hard to factor, is it's going to show you our x-intercepts. And those x-intercepts, there could be 1, there could be 2, but x-intercepts are when x is a value and the y is 0. So it's going to be whatever you see P, and then y is 0, and then q was 0. Okay? The other thing that's going to be really important that I mentioned just briefly before was A. A is going to tell us the shape. So all of these shapes are some type of U, but sometimes that U is going to flip upside down, and it's going to look maybe more like a lowercase n. So if you see this A, and it's all part of that leading term, the one right in front, being positive, then your shape is going to look like this. And if it's negative, it's going to flip upside down. You can kind of think of it as n negative, and that looks like an lowercase n. Overall, all of these shapes are called a parabola. It looks like parabola, but it's parabola. So let's talk about, now that we have this, what do you need in order to graph a quadratic? And here I'm going to do a little bit more explaining of why some of these things happen here, okay? So the first thing you're going to want to do is once you get an equation is you want to see what form it's in. Because when you know what form it's in, it's going to tell you that key point. So again, when there's no parentheses at all, just all addition, subtraction, we call that standard form. And the key point it's going to be telling me, running out of a little room here, is going to be the y-intercept. Okay? And so now I'm going to show you why that works. So on a graph, when something intercepts, when it's a y-intercept, anywhere here, so if I start looking at any point on the y-axis where it would intercept y, what you should notice is that all the x values are 0. So this is 0, 10, this one's 0, 6, 0, 3, 0, -2. All the x's are 0. And what's going to happen, I just need to locate a pencil here real quick, is if you put 0 into the equation. So what I'm going to do here is I'm going to make x become 0. So I'm starting to write my ordered pair. It's too much lead. And it's going to be 2 times 0 squared minus 12 times 0 plus 10. And we're going to see what y becomes. So again, an x-intercept, or I'm sorry, a y-intercept is along the y-axis. And on the y-axis, every point has an x-coordinate of 0, 0, 4, 0, 1, 0, 7, 0, -5. So we're just making x become 0 so that we can find the y-intercept. So when you just have a bunch of numbers, this is where you follow the order of operations. And simply what the order of operations does is it takes everything that's a term, so the things separated by an addition subtraction sign, and it gets all of that down to one number. So when I'm looking here at 2 times 0 squared, the order of operations tells me, well, I should do my exponent first. And 0 squared, which is 0 times 0, is 0. And then if you take that 0 times 2, you're going to get 0 from here. And then if you go to the next spot where a term should be 12 times 0, well, that's 0. So I'm going to subtract that 0. And then this term is a constant. It will stay at 10. And so what happens is everything in your standard form where there's an x, here and here, becomes 0 because 0 times whatever this is 0. Here 0 squared is 0, and 0 times whatever number that is becomes 0. So you essentially will always end up with 0 plus whatever number this happens to be. So in this case, I end up with 0, take away 0, adding 10, I end up with 10. So right now, I can take 0, 10, it's a y-intercept, and go to my graph and put a point right there at 0, 10. And we're going to start to make a graph. The next form is vertex form. So vertex form and factor form, we've talked about this before, are very similar in the fact that they both have parentheses. But vertex form has the parentheses with the squared on it. So this is called vertex form. And up here, I told you that the vertex was going to be whatever the opposite of h was, that would be your x-coordinate. And then your y-coordinate is going to be k. And I want to show you why that works. All right? So here, h, when I look at it, the formula is built in with the minus. So when I see minus, that's what I want. So basically, when I look at this number, no matter what, just take the opposite of it. So when I see -3, that's what I want you to see. I want you to take the opposite of that. And that means my x-coordinate, so, is going to be 3. So let's see what happens. If I make x become 3, because that's essentially what I'm doing, and I put it in here, let's see what we get. And before I do that, let's remind ourselves that we're about to get the vertex. Okay? So from the vertex, here we go. Putting 3 in, sorry, losing my train of thought. I'm going to use a pencil. So I'm going to have 2 parentheses, 3 in for x, take away 3, square that, subtract 8, and then we're going to get our y value. So again, this is just a bunch of numbers, so I just want to follow the order of operations. So the first thing I do in PEMDAS is my parentheses, and 3 take away 3 is 0. So all of that becomes 0. All right, and I'm going to run out of room, so we're just going to put it here. So 3 times 0, the 0 is still squared, take away 8 equals y. And then from there, I do exponents, and 0 squared is 0. So just dropping that down. After exponents, I do my multiplying, so 2 times 0 is 0. Drop the rest down. Oops, forgot that equal sign. And then when I'm done, I get y to be worth -8. So up here, I told you that the vertex was going to be opposite of h. So again, h is in the parentheses. Always take the opposite of what you see. That's -3. Or I'm sorry, I see -3, so I'm going to take 3. And then the y-coordinate should be k. And I want you to see k as -8. And that's actually, once we put 3 in and we did the math, we got -8. The idea here is we're just trying to find some shortcuts to get this faster. So again, here, my y-intercept, I should just be able to look at the constant. It's going to be 10. I can be able to look here and just see my vertex. It's the opposite of h, so 3, and k as is, so -8. And then the last form is factored form. And this is one of the reasons why we factored, because factored form is going to tell us our x-intercepts. So our x-intercepts are all along here, and every point here has a number in common. All the y's are 0, so this is 8, 0, 4, 0, -3, 0, 1, 0, 0, 0. You're always going to hear me saying that y is 0. So essentially, all we have to do here when we're going to find our x-intercepts, okay, and this one, for sake of time, I'm not going to go into explaining. You'll see it later. Is you're just going to go into your parentheses, and we might add this, change this, where it says P, let's add opposite of P and opposite of Q. That's going to be for now. So when I look here in my parentheses and you see -1, I want you to think 1 and the y value is 0. And go to the other parentheses, and the opposite of -5 is 5 and 0. So I take it back, I lied. I am going to show you why this works, but I'll just show you with one of them. So what I'm saying here is if I take 1 and put it in this problem in for x, so I'm going to do that right here, I should be getting y as my 0. So just dropping this down, I'm following the order of operations, doing my parentheses. 1 minus 1 is 0. 1 minus 5 is -4. And when I multiply 2 and 0 and -4, as soon as I throw 0 in for multiplying, I'm always going to get 0. So as it turns out, when I put 1 in, I do get 0. So if I make x become 1 and do this math, I get y to become 0. And the same would happen if I put 5 in here and did the math. You would end up with your y being 0. But we're going for fast things. So up here we wrote the opposite of P and the opposite of Q. So what I've already done so far here is I took this, right, and graphed it. Now I'm going to graph my vertex, so 3, -8. Make sure I'm on the right spot. Then I'm going to graph my x-intercepts. That means they should go on the x-axis, so 1 and 5. And then what's going to happen is we're going to have this like line of symmetry coming down. So the line of symmetry is always through the vertex, okay, if you remember that. And then what happens is every point on the left side has a symmetrical or partner point on the other side. So if this is my line of symmetry and this is 2 to the left, then this is the one that's 2 to the right. These are symmetrical. So up here, if I have a point that's 3 left of the line, then it will have a partner point 3 to the right of the line. And then you can make this shape right here, okay? The other thing I want you to remember is you should know the shape. And in all of these problems, this 2, this leading coefficient, this leading term, this leading, whatever you want to call it, is always 2. And since 2 equals a positive number, that means we should be having a U-shaped shape. All right? So what we're going to do is we're just going to practice, not so much graphing right now, but just if you see the form, can you quickly tell me what you get? So that's what's going to happen here. So you're going to be doing this practice, and I'm going to walk through a few of these with you, and then I'll help you get started. So I'll take care of the first row, and if you've noticed, you're going to be doing, for each quadratic function, you're going to draw the shape. You're going to state what form it's in. Then you're going to give the key point, and then you're going to tell me the ordered pair. So I've set up 1, 2, 3, but you're going to continue that with 4, 5, 6. So when you get to 4, 5, 6, just write part A, part B, part C, part D. All right, so my first form is, and you don't have to go in any particular order, so I'm actually going to start with the form. This is in factored form. I am going to abbreviate. I do need an A, and there's an invisible 1 hanging out in front, so since that's positive 1, I'll have a shape that looks like that. The key points that factored form always tells me is the x-intercept. And if you don't remember, just look back at your notes. We did make that a little addition. Just do the opposite of p. P is the number in the parentheses, and q is the other number in the parentheses. And you always just do the opposite of what you see, and you make the y value 0. So here, if I see -3, I want 3 with 0. And when I see 1, I want -1 with 0. So the next shape is vertex form, because it has the parentheses squared. My shape is also going to be a U, and I know that because of this 4 in front. Since that is positive, I should have a U shape. The key point that vertex form tells me is always the vertex. And from there, again, go back to your notes. You want the opposite of H. So eventually, when I see you in Algebra 2, if I see you in Algebra 2, H is going to be it's going to be considered the house. And this will make more sense way down the line in Algebra 2, but a house has walls. So always do the opposite of what's in the house, and then take the other number behind it, K as is. And H and K always have addition and subtraction signs with them. So here my house, I see 1, so I'm going to take the opposite of that, and then I'll take K as is, and you should see that as a -3. And then the last one, this is also in vertex form, so I'm actually not going to do this with you, but I want you to see how this is the same. The only thing that it's missing is the K at the end. So if I add or subtract anything, what's the invisible number that I can add with that doesn't change anything is going to be 0. So that's a quick little thing there. Let's do one that's in standard form. So 4 is in standard form, so that's what I would put in spot B is standard form. A is the shape, and again, there's a 4, so since A is positive, it should look like this. Standard form always tells me the y-intercept, and if you don't remember, you go back, and the y-intercept is always when x is 0, and then it's the constant at the end. So I'm just looking for that number. So the number at the end, the one with no x attached to it, is 1. And so that's what you're going to do on the next couple of problems. So the one that might trick you is going to be number 6, and what you think that is. This is actually factored form, and to make it look like factored form, I'm just going to put x in parentheses, and if I do need an add or subtract, again, the number I can add or subtract that doesn't change anything is going to be 0. Okay, and I could have made that -0 too, so just keep that in mind. All right, that is it. So you're going to be working on that section.